Hello all, good morning. So today I am going to continue with the next part of module 5, that is numerical method to solve the algebraic equation, or in a simple way we tell that to find the real roots of the given equation. So in this we have two types of methods. One is regular falsi method and one more is Newton-Raphson method. So these two methods are used to find the real root of the equation using numerical method, not by solving the equation by any of the means. So first we will go with the regular falsi method. You just remember the formula. Regular falsi is given by x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. So whichever question they ask, always first thing is we should know where that root lies. Root means what? Whenever we substitute that value of root in the given equation, it should become 0, correct? For example, if we have x square minus, for example, if we have x square minus 1 equal to 0, what will be the value of x here? In this case, we'll get x is equal to plus or minus 1. That indicates what? When I substitute x equal to 1 here or minus 1 here, we'll get this value as 0. Same way here we will be having different types of equations, and we have to find the root of that equation. So first method is regular falsi method. So whenever you start with these methods, first thing we have to check where the root lies. That root should be always between the negative and the positive value. So I will be explaining you along with the example. So I have an example here. Using regular falsi method, find the root of the equation x into e power x minus cos x is equal to 0. So first thing is we need to find, as I said, where the root lies. So for that what you have to do is, so they have given you a function f of x is equal to x into e power x minus cos x. First what you do is you go on taking the values for x. I mean, this is just like a trial and error. Take x equal to 0. When I take x equal to 0 here in this equation, I'll get the value as minus 1. And one more thing, whenever cos x is there, remember one thing, we have to keep in radians. This is very important. You have to keep the calculator in radians before starting. So first you keep your calculator in radians, then you calculate. I have taken the value for x as 0. When I take x equal to 0, I'll get minus 1, that is less than 0, which is negative. And I'll go for x equal to 1. When I take x equal to 1, I get a positive value, that is the function value is positive. So then here you stop your procedure. Means once when you get a negative value and when you get a positive value, you stop the procedure. Then what you do is, in order to get more accuracy, you go for the middle value. I mean, we'll go for the point values. So you can just check here in the number system. For 0 I got negative root, and for 1 I got a positive root. So I have stopped here. Next I am going for f of 0.5. I will directly hit the middle point. So when I tried for 0.5, again I got negative root. So again negative. So what happens? So here in the number system at 0.5 I got a negative value. Even at 0 I had got a negative value. So what I can tell you, now I'll cut this value and I'll tell you that the root lies between 0.5 and 1. Correct? So then I tried for 0.6. 0.6 I got a positive value. So right here, so cut this one value. Now I can tell that the root will lies between 0.5 and 0.6. That is, at 0.5 I got the value as negative, and at 0.6 I got the function value as positive. So this is your first step. Whichever problem they ask, first you have to find where the root lies between. Which point? Sometimes it may be lying between 2 and 3. Sometimes it may be lying between 2.5 and 2.7. That all depends on these calculations. Or sometimes in the question they'll directly give you where the root lies between these two values. If they give you, it is well and good. If they don't give you, this is a procedure what we have to follow. Okay. After getting this, now I have to go for the first iteration. So my first iteration formula is x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Substitute the values. You know what is a? A is 0.5, f of b 0.2679 minus b is 0.6 and f of a is minus 0.0532 divided by f of b minus f of a. So we'll get one root, x1 is equal to 0.5166. Initially there were two roots, 0.5 and 0.6. Now we got one more root, 0.5166, which is between 0.5 and 0.6. As soon as you get the root, check its function value. What will be its function value? So f of x1 I checked, I came to know it is minus 0.00351, which is strictly negative. So now what happened in the number system? Just we'll check our number system now. So our number system, initially the roots were lying between 0.5 and 0.6, where at 0.5 we got a negative value, 0.6 we got a positive value. Now I got a new root, that is your x1, which is 0.5166, and that's value is negative. So now which I can leave? I can leave 0.5. So you have to continue this procedure until you get the value as some 0.000 something. Okay, now the easiest way to do this is by doing in terms of a table. So write the table in this format. First write A, its function. So first write A, its function value f of A, then write B, its function value f of B, then the root x is equal to, write the formula, A into f of B minus B into f of A by f of B minus f of A, then write f of x, that is the given equation. Okay, so in the first iteration A was 0.5, write its value, function value, B was 0.6, write its function value, then we calculated x, we came to know that it was 0.5166, write it, and its function value is minus 0.00351, which was negative. So whenever you get a negative, we have to replace which value? We have to simply replace it with A, and whenever you get positive, we have to replace it with B. That is a simple concept, that's it. So what I am telling you, listen carefully, your f of x, if you are getting negative, just replace it with the value of A. If you are getting positive here, you just replace it with the value of B, that's it. Okay, that is a procedure. So now here I got negative minus 0.00351, so I have to replace it with which one? A. So I can just observe here, for the second iteration, in the place of 0.5 I am replacing it with 0.5166, and its function value is minus 0.00351. That's why I put a arrow mark and this underlined, overlined. And B value and f of B value I am keeping as it is, 0.6 and 0.2679 as it is. Then again you calculate, we have the formula, this is the value of A, f of A, B, f of B, substitute it, we'll get the value as 0.5177, that is in the second iteration. As soon as you get this, you find the function value. Function value we get minus 0.00017. So you can see here, it is approaching 00 very faster, correct? Again this value is negative. If it is negative, what I have to do? We have to replace it for which one? A or B. So obviously whenever it is negative, we have to replace it for A. So again you can check here, initially it was 0.5166, now I have replaced it with 0.5177, its value minus 0.00017, and B value I am keeping it as it is, and then when I calculate, I am getting the value of x as same value, 0.5177. So stop the procedure here and tell that therefore the real root of the equation is 0.5177.